trends and innovation, speed and resolution, improvement, multi-material printing, 4D printing, shape-shifting objects, printing living tissues and organisms, sustainable and eco-friendly materials. 7 is change and limitation, material properties and consistency, scalability and cost effectiveness, post-processing and finish, standardization and regulation. Here are some additional 3D printing topics. First is 3D printing in space, printing in microgravity environment, application for space exploration and habitation. Second is 3D printing for education, enhancing STEM education with 3D printing. Classroom application and projects. Third is 3D printing in healthcare, custom implement and prosthetics, surgical models and planning, personalized medicine and pharmaceutical. 4 is 3D printing in automotive, repaid for the prototyping and production. Lightweighting and structure components, customization and aftermarket parts. 5 is 3D printing in aerospace. Lightweight and structure component, repaid, prototyping and production. Satellite and spacecraft components. 6 is 3D printing in fashion, customized clothing and accessory, repaid prototypes and productions, sustainable and eco-friendly materials. 7 is 3D printing in architecture, building scale models and prototypes, customized building components and facades, sustainable and eco-friendly construction. 8 is 3D printing in art and design, creative expansion and innovation, complex geometries, geometrized and structure, customized and personalized art pieces. 9 is 3D printing in food and culinary, customized food products and ingredients, repaid prototyping and production, sustainable and eco-friendly eco-friendly food system. 10 is 3D printing in sports, customized equipment and gear, repaid prototyping and production, enhanced performances and safety. Here are some additional 3D printing types. First is 3D printing safety, hazard and risk associated with 3D printing, safety protocols and best practices, ventilation and air quality. Second is 3D printing regulation, intellectual properties and crypto and copyright laws, product safety and liability regulation, environmental regulation and sustainable. Third is 3D printing business models, servers, bureaus and contract printing. Hi guys, how are you? My name is Sardar Tayyab and today topic is human machine interface. Let's start it. Human machine interface HMI refers to the interface between a human operator and a machine or system, enabling communication, control and monitoring. Here are some topics related to HMI. First is design principles, user centered design, intuitive interface and ergonomics. Second is display service monitoring, touch screen, LCD displays and LED indicators. Third is input devices, keyboards, mic, touch screen, joystick and sensor. Four is software, graphical user interface, GUIS, SCADA system and industrial automation software. 5 is industrial automation, HMI, in manufacturing, process control and automation. 6 is IoT and HMI, integrating HMI with IoT devices and systems. 7 is augmented reality, AR, HMI, using AR to enhance HMI experience. 8 is voice command HMI, using voice recognition technology for HMI. 9 is gesture based HMI, using gesture recognition technology for HMI. 10 is accessibility design HMI for user with disability and limitation. 11 is usability testing, evaluating HMI effectiveness and user experience. 12 is HMI standards, industry standards and guidelines for HMI designs. 13 is HMI security, ensuring security and cryptography, cyber security in HMI systems. 14 is remote HMI accessing and controlling system remotely through HMI. 15 is mobile HMI, using mobile devices as HMI interface. Here are some additional topics related to human-machine interface HMI. First is artificial intelligence AI HMI, integrating AI technology into HMI systems. Second is machine learning ML HMI, using ML algorithms to improve HMI performances. Third is natural language processing NLP HMI, using NLP technologies for voice, command and text based HMI. 4 is computer vision HMI, using computer vision technology for gesture recognition and object detection. 5 is HMI for autonomous system, designing HMI for autonomous vehicles, drones and robots. 6 is HMI for smart homes designs, HMI for smart home systems and IoT devices. 7 is HMI for variables designing, HMI for wearable devices and augmented reality glasses. 8 is HMI for virtual reality VR and augmented reality AR, designing HMI for impressive experience. 9 is HMI accessibility standards, ensuring HMI accessibility for users with disabilities. 10 is HMI usability guidelines, best practices for designing a user-friendly HMI. 11 is HMI testing and evaluation methods for testing and evaluating HMI effectiveness. 12 is HMI design tools, software and tools for designing and prototyping HMI. 13 is HMI development frameworks for buildings and integrating HMI systems. 14 is HMI security protocols, ensuring secure data transmission and authentication in HMI. 15 is HMI for edge computing, designing HMI for edge computing devices and systems. Here are some additional topics related to a human-machine interface HMI. First is HMI for Industrial Internet of Things IIoT, designing HMI for IIoT devices and systems. Second is HMI for cyber physical systems, designing HMI for for cyber physical system and industry 4.0. Third is HMI for autonomous framing, designing HMI for autonomous framing equipment and system. 4 is HMI for medical devices, designing HMI for medical devices and healthcare system. Hi guys, how are you? My name is Sardar Tayyib and today's topic is deep learning. Let's start it. Deep learning is a subset of machine learning that involves the use of artificial neural networks to analyze and interpret data. It's called deep because this network have multiple layers allowing them to learn complex patterns and relationship in data. First is key aspects deep learning. First is neural network. Inspired by the human brain, neural networks are composed of layers of interconnected nodes, neurons that process and transmit information. Second is layered deep learning model typically have multiple layers, each processing and transforming the data in a different way. Third is activation function. Each node applies an activation function to the data, introducing non-linearity and allowing the model to learn complex relationships. 4 is propagation in an algorithm used to train deep learning models by minimizing the error between prediction and actual outputs. 5 is large amount of data. Deep learning models require vast amount of data to learn and generalize well. Application of deep learning. First is computer vision, image recognition, object detection, segmentation and generation. Second is natural language processing, NLP, text classification, language translation, sentiment analysis and chatbots. Third is speech recognition, voice assistance, speech to text system and voice recognition. 4 is robotics control and navigation system of robots. The five is healthcare medical image analysis, disease diagnosis, and personalized medicine. A popular deep learning framework first is TensorFlow, second is PyTorch, third is Keras, 4 is Caffe, 5 is Microsoft Cognitive Toolkit CNTK. Here are some additional aspects of deep learning. First is type of deep learning models. A is convolutional neural network, CNNS. Second is recurrent neural network, RNNS. C is generative adversarial networks, GANS. D is transformers. E is authenticators. First is deep learning techniques, transfer learning, fine tuning, batch normalizing, dropout, regularization. Deep learning application, image generation, image to image translation, video analysis, natural language generation, time series prediction. Deep learning tools and libraries, TensorFlow, PyTorch, Keras, OpenCV, scikit-learn. Deep learning challenges our underfitting, vanishing gradients, exploding gradients, adversarial attacks. Deep learning research, deep learning for computer vision, deep learning for NLP, deep learning for robotics, deep learning for healthcare, deep learning for financial. Let me know if you had like explore any of these topic further allows. Also I can provide you research papers and article, online courses and tutorials, books and other resources, industrial repos and analysis, code examples and implementation. Here are some additional deep learning topics. First is explainable AI, XAI, techniques for interpreting and explainable deep learning models. Second is adversarial robustness methods for defined defending against adversarial attacks on deep learning models. The third is transfer learning, using pre-trained models for new tasks and domains. 4 is multitask learning, train a single model for multitask simultaneously. 5 is meta learning. Hi guys, how are you? My name is Sardar Tayyab, and today's topic is computer-aided manufacturing. Let's start it. Computer-aided manufacturing (CAM) is the use of computer software to control machine tools and manufacturing process. Here are some topics related to CAM. First is CNS machine. Using CAM software to control CNS machine for milling, turning and grinding. Second is 3D printing. Using CAM software to control 3D printing processes like FDM, SLA and SSLS. Third is robotics. Using CAM software to control robotic arms and cells for welding, assembles and inspection. Fourth is milling and turning. Using CAM software to optimize milling and turning operation. 5 is grinding and finishing. Using CAM software to control grinding and finishing processes. 6 is EDM and wire EDM. Using CAM software to control electrical discharge machines EDM and wire EDM. 7 is laser cutting and engraving. Using CAM software to control laser cutting and engraving processes. 8 is water jet cutting. Using CAM software to control water jet cutting processes. 9 is plasma cutting, using CAM software to control plasma cutting processes. 10 is CAM software. Popular CAM software includes Mastercam, SolidWorks, CAM Fusion 360 and PowerMill. 11 is post-processors, using post-processors to translate CAM data into machine-specific code. 12 is G-code and M-code, understanding G-code and M-code programming for CNS machines. 13 is toolpath optimization, optimizing toolpath for efficient machines and reduce materials waste. 14 is machine simulations, simulating machines movement and process to ensure accuracy and safety. 5 is CAM for additive manufacturing, using CAM software to control additive manufacturing processes. Here are some additional topics related to computer-aided manufacturing, CAM. First is CAM for aerospace manufacturing, using CAM software to control manufacturing processes for aerospace components. Second is CAM for automotive manufacturing, using CAM software to control manufacturing process for automotive components. Third is CAM for medical devices manufacturing, using CAM software to control manufacturing process for medical devices. 4 is CAM for molded and die manufacturing, using CAM software to control manufacturing process for molds and dies. 5 is CAM for shop manufacturing, using CAM software to control manufacturing manufacturing processes for shops and contract manufacturers. 6 is CAM for production planning, using CAM software to plan and optimize production processes. 7 is CAM for quality control, using CAM software to control quality inspections and testing processes. 8 is CAM for supply chain management, using CAM software to manage supply chain operation and logistics. 9 is CAM for Industry 4.0, using CAM software to enable Industries 4.0 technologies like IoT, AI and machine learning. 10 is CAM for digital twinning, using CAM software to create digital twins for manufacturing processes and systems. 11 is CAM for augmented reality, using CAM software to enable augmented reality application in manufacturing. 12 is CAM for collaborative robotics, using CAM software to control collaborative robotics and cobots. 13 is CAM for 3D printing post-processing, using CAM software to control post-processing operation for 3D printing parts. 14 is CAM for composite manufacturing.